Question number 81. Which of the following rule is violated while writing the electronic configuration of copper atom? So first rule that's given here is Hund's rule. It states about the pairing of electron. As per this rule, pairing in an orbital occurs when all the orbitals are singly occupied. Again, the Pauli's exclusion principle. It states that no two electrons have the same set of all four quantum numbers, while this Aufbau principle states the filling of electron occur as per the increasing energy level. Heisenberg uncertainty principle is not related to the filling of electron. So, first we have to check what is the electronic configuration of copper. It is 4s1. 3d10 exceptional electronic configuration, and in this case one electron from 4s orbital is coming to the 3d orbital. So if we talk about Aufbau's principle, it states that the electron is filled in that energy level first which has lower energy. So on that basis, first electrons should be filled in 4s orbital, not in 3d, because 4s has less energy as compared to the 3d orbital. But in this case, for the sake of stability, for the fully filled electronic configuration, this d orbital is fully occupied, then one electron is remaining in this s orbital. That is why it is violating Aufbau's principle. So this configuration violates Aufbau's principle. And yes, the correct answer is option 3. Now, after this, we have the given question. Question number 82. Splitting of spectral lines under the influence of electric field and magnetic field are respectively called. In this case, we have the given options, Zeeman effect and Stark effect. The second option, Stark effect and photoelectric effect. Third option is Stark effect and Zeeman effect. And then we have photoelectric effect and Zeeman effect as the fourth option. So here first we have to know that if we are talking about the splitting of spectral lines under the influence of electric field and magnetic field. So we should know that if we talk about Zeeman effect, that is the splitting of spectral lines under the influence of magnetic field. While if we talk about Stark effect, that is the splitting of spectral lines under the influence of electric field. So here the effect of electric field would be there. While if we talk about photoelectric effect, that is the emission of electron when light falls on the surface of metals. So this is not the photoelectric effect. So the correct option for this particular question is Stark effect and Zeeman effect. That's given in option 3. The answer for this particular question is option 3. I hope this question is also clear to you. Now let's move on to the next question. Question number 83. The number of lone pairs of electrons in I3 positive ion and its shape respectively are. So here we have this I3 positive ion. And in this case, I just want to draw its structure. There are 3 iodine atoms which are joined in this manner, and the lone pairs associated with central atom is 2, which are participated in hybridization also, while these are the bonded pairs. This way. So this is the structure of this, and that we have find out with the help of the formula that the hybridization can be calculated with the help of the total number of sigma bond plus the lone pairs. So how many sigma bonds are there? You can clearly see 2 sigma bonds are there. And how many lone pairs which are participated in hybridization? 2 lone pairs are there. So that's why 4 is the total number of sigma bond and lone pair, and with the help of that we can say the hybridization is sp3. So its structure should be tetrahedral. So that we have drawn here, and now on the basis of this, what would be its shape? Its shape would be bent. Bent shape. And what is asked in the question? The number of lone pairs. So just count the number of lone pairs. There are 1, 2, 3, 4, 5, 6, 7, 8. Total 8 lone pairs are present and the shape is bent. So first option is the correct option. Right here, the correct answer, that is option 1. I hope this question is also clear to you. Let's check the next question. Question number 84. Pi bond is absent in. We have to find out that compound in which pi bond is absent. We have the 4 options given here. First we have Al4C3. So if we talk about this, this is an ionic compound. Aluminium ion is there. And there is carbon in 4 negative state, anion. Then we have CaC2. So if we talk about this, this is Ca2 plus calcium ion, and there is C2 negative ion. If we draw the structure of this, it is ethynide ion basically in this way. Then we have the next C2, diatomic carbon. This is diatomic carbon. And its bond order is 2. It means as per molecular orbital theory, it has 2 pi bonds. So let me first write here, it has 2 pi bonds, diatomic carbon. While if we talk about this ethynide ion, it also contains 2 pi bonds. Now, the last is C2H4, ethene molecule, and we know that ethene molecule has 1 pi bond here. So it also has 1 pi bond. It means the pi bond is absent in the first compound, that is Al4C3, and that's why correct option is option 1. I hope this question is also clear to you. Let's move on to the next question. Question number 85. The diamagnetic species is. What are diamagnetic species? The species in which there is no unpaired electron. So, in case of diamagnetic species, there are no unpaired electrons. So let's check the first option, KO2, potassium superoxide. In this case, we have O2 negative ion that has unpaired electron. Further, we have ozone molecule. In this case, there is no unpaired electron. That's why it is diamagnetic species. But let's check the next also, NO2, nitrogen dioxide, that also contains unpaired electron, because this is the molecule which is termed as odd electron molecule. Similarly, if we talk about ClO3, in this case, this chlorine atom also has the unpaired electron. That is why the correct answer for this question is option 2.